Hey guys, happy Thursday. So again, I'm not here today and I do apologize for that. I will definitely be back tomorrow. Um, so today we're going to talk about arc measure. Again, we're still involving circles. Again, arc is a little stretch out on the edge of a circle. But we're going to talk about the difference between when I say arc measure and then arc length, because these are two different things that often get confused. I sometimes accidentally interchange these. So again, that's what we want to focus on today. What is the arc measure? So again, by today, you should know what arc measure is. We should be able to define it. And again, make sure we don't accidentally confuse it with arc length. So what is the actual definition? Okay, well, what do we mean in geometry when we mean arc measure? It's the measure of the central angle that intercepts the arc. So again, if I'm talking about, for example here, measure of arc AB. So if I go from A to B, so if I'm talking about this piece right here, this minor arc, what is the measure of the central angle? Well, the angle, again, that intercepts it, this angle that's created in the inside measures 120 degrees. That's what the arc measure is referring to, the angle on the inside, how much it's 120. Okay, very similarly, if I wanted to use the major arc ACB, if I want to go the other way around, let me use a different color here, let me use orange. If I want to go from A all the way in this direction through C and then get to B, well, what is this angle that's created here? What's that angle? It's kind of weird, right? Well, how many degrees inside of a circle? We have a total of 360 degrees, and how much is already taken up? 120 was taken up by the minor arc, so minus 120. We get 240 degrees. This major arc, the measure of it is going to be 240 degrees. And again, it's not the length. It's not like I'm taking a ruler and I'm measuring the distance from A to B or from A through C to B. No, I'm referring to the inner central angle. Okay, so take a second, copy this down. All right, so let's jump into our examples here. So example number one, take a second. Again, make sure you guys copy the actual question. It's very important. What the heck are we figuring out, right? And then the actual picture here. So take a second, copy down, and we'll get started. All right, so this one's saying, hey, what is the arc measure? So what's that central angle of arc AC on the circle P below? So P is our center here. So again, if I'm referring to the arc from A, from point A all the way to C, so I know it's the minor arc, so I want to go through the shortest distance. Now you see this is kind of slightly angled here, so it's referring going in this direction. So what I want to know is, what is that central angle that intercepts it? So from here, what is that angle that's created on the inside? Well, the issue is it's broken apart into two different angles. Well, if I want the whole thing together, what do I have to do? Just add those guys. What is 104 degrees from this guy plus the 70 degrees from the other? That is a total of 174 degrees. So the measure, okay, the arc measure of AC is going to equal 174 degrees. There's 174 degrees that suspend this arc here. All right, let's move on to the next one. Okay, example 2. Take a second, copy it down, copy down the picture. All right, let's go. Example 2. In the figure below, all right, so it says in the figure below, AD and CE are diameters. So in other words, they go from the edges and they cut the circle right through the exact center. So let me mark this. So from A to D, that is a diameter, cuts my circle right in half. And then from C to E, so from C to E, that also cuts my circle down in half. So again, I might have to use that idea in a second. Are the diameters of circle P. Again, P is the center of my circle. What is the arc measure from A to B? So I want to go from A, and again, it's using two letters, so I'm referring to the minor arc, the shortest distance from A all the way to B. I want to figure out what is the central angle that is in between there. I want to figure out this little piece right there. Well, how do I do that? There's multiple ways we can approach this. Now, what I want you guys to do is going back to our definition of a diameter. So let me get rid of that guy. If I just take a look at that red line, that first diameter from A to D, well, technically what it did was it cut my circle into halves from A, B, C, D, that half, and I cut it to the other half, A, E, D. Well, if I cut a circle in half, I know there's 360 degrees in a circle. Well, if I cut it in half, that means I'm dividing by 2. If I divide it by 2, well, I just created half a circle, a semicircle. There's only 180 degrees on this side. There's 180 degrees on the other side. So what I want to do is, if this is 180 degrees here from A to E to D, and I've already got 93 degrees used up, how much more do I need to complete that whole 180? Well, what's 180 degrees minus the 93 degrees? What's 180 minus 93? That is going to give me a total of 87 degrees. There's 87 degrees in that little angle there from A, P to E. Okay, well, how does that help me? I'm still not where I want it to be. I want to know this orangey one in here. Well, let's take a look at the other diameter. The other diameter, see if I can use a different color here. Use light blue. CE, this guy also cut my circle in half. So I know that this half is 180, and I know that this half is 180. Well, it's broken up into 3 pieces. This angle, the orange one, and the red one. That's 180 degrees right there. Well, I know what the blue one is. It's 38 degrees. I know the red one is 87. How much more do I need for 180? Well, I'm going to take 180, and what am I going to do? Let's go ahead and subtract 180 minus the 38. Okay, and we get 142. Now, there's 142 degrees left here, but if I subtract the minus 87 degrees as well, minus another 87 degrees, I get 55 degrees left. Now again, what is that 55 referring to? That is that angle right there. That is 55 degrees. So the measure of arc AB, so the measure of AB, of arc AB, is going to be 55 degrees. There we have it. So again, you have to use the definition of diameter, the idea that it cuts a circle in half. Now we could have gone the other way and still would have gotten the same thing here. All right, let's move on to example 3. Same deal. Take a second. When you're ready, hit play. All right, in the figure below, AB is a diameter. Sorry, we might have to use that again. That's cutting my circle in half. I know that top half up here is 180 degrees. The bottom half is 180 degrees. Okay, what is the arc measure of ABC? So now they want the major arc. How do I know it's a major arc? It's using 3 letters. So I better go the long way. So from A, go all the way around to B, cross it, and continue to C. So I want to know what the central angle is all the way around. That is a pretty large angle. Well, how can I figure it out? Remember, use that definition of diameter from A to B. That broke your circle here in half. That means there's 180 degrees on this side, 180 degrees on the other side. Well, now it's just composed of 2 pieces. This is 180 degrees plus the 69 degrees. So again, if I want the angle inside here from A all the way through B to C, that's just 180 plus 69 degrees. So 180 plus 69 degrees is 249 degrees. In total here, there's 249 degrees for the measure of arc A, B, C. That would be 249 degrees. All right, on to the next one. Again, take a second, copy it down. When you're ready, hit play. All right, for example 4, what is the arc measure of BC? So from B all the way to C, the minor arc, the shortest distance, they use 2 letters, so we're going to assume it's the shortest distance. Well, I want to know this angle. The issue that I have is, I don't even know what the heck K is. I need to figure out K. If I can figure out K, I'm going to know, I just have to plug it back in and actually get the degrees. All right, so how can I figure this out? I have 2 lines that are crossing, and guess what? Well, what do I know about this guy, and what do I know about this guy? These are going back to semester 1. call vertical angles, and we know vertical angles are absolutely, they are equal to each other. So I can say 4k plus 159 is equal to the 2k plus 153. All right, let's go ahead and solve this multi-step equation. Minus 2k minus 2k. So I get 2k plus 159 is equal to 153. Okay, so now what do? I have to subtract. Let me do this. Minus in a different color. 159 minus 159. Cross those off. I get 2k is equal to, what is 100? Whoa. 153 minus 159 is going to give me negative, what is that, 6? Okay, the last thing that I have to do here is divide both sides by 2. Now again, careful, don't panic. You're like, hey, k is equal to negative 3. Oh my god, I did something wrong. Oh my god, the world's going to end. I can't have negative degrees. Well, you're absolutely right. You cannot have negative degrees. That's not what I'm looking for. That's the value of k. What I have to do is I have to take that and I have to plug it back in. Again, I wanted the measure of arc BC, so I have to plug it back into this top one here. So let's go ahead and show our work on this side. So 4 times negative 3 plus 159. So what is 4 times negative 3? That is negative 12 plus 159. So 159 minus 12 is going to be 147 degrees. So there we have it. When I plugged it back in, the measure, I want to go back and make sure I put the measure of BC, of arc BC, is equal to 147 degrees. There's 147 degrees that suspend that arc right there. All right, got one last one. Okay, this one says, what is the arc measure of BC? So I want to know from B, let me use a different color here, from B all the way to C, but I want to use the shortest distance because they only use 2. So I want to go, looks like this way it's going to be shorter. So I want to go in this direction. All right, and that's all they give you. So what the heck? What is going on here? Well, I need to figure out, first of all, what the heck y's are, right? The value of y. If I can plug that in here and plug that in here, I'll know the actual angles. Well, how many degrees inside of a circle? There's 360 degrees. So if I add this piece plus this piece plus this piece, there's a total of 360 degrees. So I have to say 4y's plus 6 plus 7y's minus 7 plus the big piece over here, 20y minus 11. All three of those, if I combine them, I get 360 degrees. And again, this is just a matter of combining like terms here. Let's go ahead and say that's 4y's, 11y's. That's going to be 31y's. Okay, let's go ahead and combine our nice whole constants. I'm going to use a different color here. 6 minus 7, that's negative 1. Negative 1 minus 11 is negative 12. Is equal to my 316 degrees. All right, let's go ahead and solve this. What I have to do next, I do plus 12 plus 12. That is 31y is equal to 372. Last thing I do is divide both sides by 31. 372. Let me put this in calculator. Divided by 31 is 12. Y is equal to 12. Now I'm running out of time here, so I'm going to pause the video, show a little bit of work, and then I'll hit play. Sorry, so y is equal to 12. What I did was I plugged it in here, and I plugged it in here because I wanted a distance from B to C, and I got 54 and 77. So if I add those two, I get 131 degrees. That is the central angle. All right. So here is your guys' class activity. So again, make sure you guys copy it down, take a second, work it out. Make sure you guys turn this in. Have a great day. I'll see you guys tomorrow.